Why am I having so much trouble scaling my AI project? A lot of the time, it comes down to one decision: prompting, fine-tuning, or RAG. If you're a tech leader or architect deciding how to adapt large language models to real business needs, this video will help you choose the right approach. We'll break down how RAG versus fine-tuning versus prompt engineering work at a system level, and when each one actually makes sense in production. We'll look at architecture, components, workflows, and the trade-off that impacts results, ROI, and time to market. And at the end, I'll share a simple way to think about combining them. Let's start with the simplest one: prompt engineering. Prompt engineering is the fastest way to influence an LLM, not by training it, but by designing the interface between your system and the model. Instead of changing the model weights, you are shaping behavior through structure instruction, examples, constraints, and output formats. In practice, that often includes templates, prompt chaining, and lightweight guardrails. Architecturally, it's the simplest setup: a base LLM plus a prompt layer, no training pipeline, no extra data infrastructure. That's why prompting is the ideal for early experiments and quick iteration. You can change behavior in minutes, but there's a limit. Prompts don't add new knowledge, and as requirements grow, prompts can become fragile, harder to maintain, harder to test, and easier to break when edge cases appear. The moment your prompt starts turning into a mini programming language is usually a signal you need a stronger approach. Fine-tuning. Fine-tuning is a more structural approach. Instead of shaping the question, you modify the model itself so that a certain behavior becomes more consistent. Technically, that means updating the model weights using curated examples. So the model learns patterns, tone, format, domain, rules, and decision logic. Regarding architecture, this introduces a new layer: training data, a fine-tuning pipeline, evaluation, and versioning. It's slower to iterate, but the results can be much more stable. Fine-tuning works best when the task is relatively narrow and stable, and consistency matters more than flexibility. For example, generating outputs in a strict format, following policies, or adapting to a domain-specific writing style. The trade-off is operational overhead. You're committing to training workflows, governance, and long-term maintenance. And if your underlying knowledge changes frequently, fine-tuning quickly becomes expensive to keep updated. Overall, fine-tuning is great for stable behavior, but it's a poor tool for keeping knowledge current. Retrieval Augmented Generation, or RAG. RAG solves a different problem altogether. It doesn't change the model's behavior, it changes what the model knows at runtime. Instead of retraining, you connect the model to external data. When a query comes in, relevant information is retrieved and injected into the prompt before generation happens. This adds a few architectural components: embeddings, a vector database, a retrieval layer, and the LLM itself. But the workflow stays flexible. You can update knowledge without retraining the model. The challenge moves from training to retrieval quality. Chunking, relevance, and grounding becomes the new bottlenecks. RAG shines in enterprise scenarios where data changes frequently, traceability matters, and hallucinations are costly. It also reduces long-term maintenance since updating content is faster than retraining models. For many teams, RAG offers the best balance between control, cost, and speed to production. When you compare these approaches side by side, the difference becomes clearer. Prompt engineering is fast and lightweight, but limited. Fine-tuning delivers consistency, but at a higher cost and slower iteration. RAG adds a data layer that keeps system flexible and up to date. They are not mutually exclusive in practice. Most mature systems use all three at different stages. Prompting is great for speed and early validation. Fine-tuning is valuable when stability and precision matter. RAG is ideal for knowledge-heavy systems that need to evolve over time. From a time-to-market perspective, RAG often reduces delays by avoiding retraining. From a cost perspective, it usually scales better as data grows. These approaches are complementary tools. The real question for tech leaders is which problem you are solving right now and how that decisions affect architecture, result, and ROI. If you are building or scaling AI system in productions, we'd love to hear what approach you are using and why. Drop it in the comments and don't forget to subscribe for more practical insights on real-world AI system. Until the next one, happy coding.